Question number 3a. Find the arc length of the ellipse x square by a square plus y square by b square is equal to 1. So we know that what is the parametric equation of the ellipse. What is the parametric equation of the ellipse? The parametric equation of the ellipse is x is equal to a cos theta, y is equal to b sin theta, where theta varies from 0 to 2 pi. Where theta varies from 0 to 2 pi. This is the parametric equation of the ellipse because the coordinates a cos theta, b sin theta is satisfying this equation. So we have to find out the equation of the whole arc length of the ellipse. Whole arc length means this length. So the total whole arc length of the ellipse, that is equal to 4 times arc length AB. So arc length of the ellipse, arc length of the ellipse that is equal to 4 into arc length AB. Arc length AB. And in parametric form, what is the arc length AB? It is equal to 4 into arc length of AB. Here from A to B, theta varies from 0 to pi by 2. Because when you take theta is equal to 0, so it becomes x is equal to A and y sin 0 is equal to 0. So the point coordinates of the point A is A0. So for theta to be 0, the point A is A0, and when we take theta is equal to 90 pi by 2, it becomes 0b. So in this arc, theta varies from 0 to 90, so it is integration 0 to 90. And what is the arc length? The formula of arc length is equal to square root of dx by d theta whole square, dx by d theta whole square plus dy by d theta whole square with respect to theta. Now, since it is equal to your 4 into integration 0 to pi by 2, x is equal to a cos theta. So what is the value of dx by d theta? Minus a sin theta whole square. Plus y is equal to b sin theta, dy by d theta, that is equal to b cos theta whole square. Its square root with respect to theta. Now it is equal to 4 into integration 0 to pi by 2. It is a square sin square theta plus b square cos square theta d theta. So it is equal to square root of a square cos sin square theta plus b square cos square theta d theta. Now in ellipse we know that eccentricity E of the ellipse is given by the equation that b square is equal to a square into 1 minus e square. E, that is the eccentricity of this ellipse, it is given by the equation b square is equal to a square into 1 minus e square. So on substituting the value of b square here, it will be equal to 4 into integration 0 to pi by 2 square root of a square sin square theta plus in place of b square we have to take a square into 1 minus e square whole into cos square theta with respect to theta. Now on further simplification, it is equal to 4 into definite integration 0 to pi by 2. It is a square sin square theta plus a square cos square theta. So a square sin square theta plus a square cos square theta, that is equal to a square minus a square e square cos square theta minus a square e square cos square theta its square root with respect to theta. Or that is equal to, now a square taking common, it is equal to 4 into taking a square out of square root, it will be 4a definite integration 0 to pi by 2, definite integration pi by 2 root over of 1 minus e square cos square theta. So that can be written as 1 minus e square cos square theta whole to the power half with respect to theta. So the arc length of the ellipse is given by 4a integration 0 to pi by 2 1 minus e square cos square theta whole to the power half d theta. Now we know that what is if 1 plus x whole to the power n, 1 plus x whole to the power n, where n is any fraction, then what is the binomial expansion of 1 plus x whole to the power n, where n is any fraction? It is your 1 plus nx plus n into n minus 1 divided by factorial 2 into x square. So next term will be n into n minus 1 into n minus 2 divided by factorial 3 into x cube plus dot dot dot, it will continue up to infinity. So this is the expansion of 1 plus x whole to the power n, binomial expansion where n is any fraction, that is 1 plus nx plus n into n minus 1 by factorial 2 into x square plus n into n minus 1 into n minus 2 divided by factorial 3 x cube plus up to, it will continue up to infinity, where we know that this x mod x, where mod x should be less than 1, where mod x should be less than 1, it is the expansion of this. Now so we'll find out the expansion taking this to be x. If we take x is equal to e square cos square theta 1 minus e square cos square theta whole to the power half. So according to this binomial expansion of this will be 4a integration 0 to pi by 2. So first term is 1 minus 1 by 2 square cos square theta plus 1 by 2 minus 1, that is minus 1 by 2 into x square value is equal to e to the power 4 cos to the power 4 theta divided by factorial 2 plus next term will be how much? Next term will be your 1 by 2, n means 1 by 2 into minus 1 by 2 into minus half minus 2 minus 3 by 2 whole divided by factorial 3 into e square cos square theta minus e square cos square theta whole cube, that is equal to minus e to the power 6 cos to the power 6 theta plus dot dot dot, it will continue up to infinity. So in the third term here you see putting n is equal to 1 by 2, it is 1 by 2 into 1 by 2 minus 1, that is minus 1 by 2 into it is 1 by 2 minus 2, that is minus 3 by 2. Again into x cube. X cube means it is here a cos theta, that is equal to your e square cos square theta whole cube. Its whole cube minus e square cos theta whole cube. It is again minus e to the power 6 cos to the power 6 theta. So here it is minus into minus, and this minus again it will be minus. So it is 1 by 2 into 1 by 2 into 3 by 2. And what is the integration of cos to the power 6 theta with respect to theta with limit 0 to pi by 2? According to Wallis formula, it is 5 into 3 into 1 divided by 6 into 4 into 2 divided by factorial 3 into pi by 2. Now here you see that pi by 2 taking common, here it is 1 minus it is 1 by 2 whole square into e square. Here it is minus 1 by 2 whole square, here it is 2 into 2, that is 4, 4 into 4, that is equal to 4 square. So it is 2 square into 4 square. Here I have multiplied a 3 in the numerator and divided with 3. So it is 3 square. So 1 square into, in the numerator it is 1 square into 3 square. Into e to the power 4 by 3. Next term is minus, it is 1 by 2 whole square, so that means it is 2 square, it is 2 into 2, 4 into 4, that is equal to 4 square into 4 square. Here it is factorial 3 is 6 into 6, that is equal to 6 square. In the numerator here you see that we will divide with 5 and it will be 5 square. So it is 5 square into 3 square into 1 square. So in the numerator it is 1 square into 3 square into 5 square whole into e to the power 6 divided by 5 minus up to infinity. So now here it is 4 by 2, that is equal to 2. So 2a pi 1 minus 1 by 2 whole square into e square minus 1 square into 3 square divided by 2 square into 4 square into e to the power 4 by 3 minus it is 1 square into 3 square into 5 square divided by 2 square into 4 square into 6 square into e to the power 6 divided by 5. Similarly, if you see, then the next term similarly it will be, we can say it is equal to 1 square into 3 square into 5 square into 7 square divided by 2 square into 4 square into 6 square into 8 square into e to the power 8 divided by 7. In this way it will continue up to infinity. So this is the arc length of the ellipse, whose parametric equation is x is equal to a cos theta, y is equal to b sin theta. 3g, we have to show that the graph of the vector valued function r of t is equal to 3 whole into cos t plus 1 into I cap plus 2 whole into sin t plus 1 j cap, that represents an ellipse we have to prove. So now the vector valued function can be written as r of t is equal to this thing, that is equal to x into I cap plus y into j cap. So that means here it is given that what is the value of x? X is equal to 3 into cos t plus 1. And what is the value of y here? Y is equal to 2 into sin t plus 1. So from here we can find out that what is the value of cos t. So cos t, from here we are getting that cos t is nothing but it is equal to x by 3 minus 1. X by 3 minus 1. Similarly, from here you can find out that what is the value of y by 2. It is equal to, sin t. Directly you can find out the value of sin t. So sin t is nothing but sin t is equal to your y by 2 minus 1. So using the identity, trigonometry identity, using the identity that cos square t plus sin square t, cos square t plus sin square t is equal to 1, we are getting that x by 3 minus 1 whole square plus y by 2 minus 1 whole square is equal to 1, and this can be written as x by x minus 3 whole square divided by 9 plus y minus 2 whole square divided by 4 is equal to 1. So it represents an ellipse. Which represents an ellipse? Which represents an ellipse? Which represents an ellipse. So we have proved that the vector valued function, it represents an ellipse whose equation, whose Cartesian equation is this thing. Okay. Find scalar triple product, that is A vector dot B cross C, where A vector is this thing, B vector is this thing, C vector is this thing. Now we know that bracketed ABC, that is your scalar triple product A vector dot B vector within bracket B vector cross C vector, and its value is nothing but it is the determinant of 237. It is the determinant of 237, 1, 1 minus 4, and it is 3 minus 2, 5. So if you expand this determinant, then it will be equal to 2 into, here it is 5, 5 minus 8, 5 minus 8, minus 3 into 5 plus 12, 5 plus 12, plus 7 into minus 2 minus 3, minus 2 minus 3. So on further simplifying, it is minus 3 into 2 minus 6, here it is 17 into 3 minus 51, and here it is minus 5 minus 35. So it is equal to 6 plus 1, 7, 7, 5, 12. So it is 6 into 3, this is 90 minus 92. So the value of this scalar triple product is equal to minus 92. That is 3i. Trace the graph of the function y is equal to 3 into sine of 2x minus 4 without expansion. Here you see that we know this is your x-axis and y-axis. On the x-axis we are taking the angles. This is 90, it is pi, it is 3 pi by 2, it is 2 pi. So we know that the graph of the function y is equal to sine x, it is 1, 0, 1. This is 0 minus 1. So sine 0 is 0, sine 90 is 1, sine pi is 0, sine 3 pi by 2 is minus 1, 2 pi is 0. So this is the curve y is equal to sine x. It is the curve y is equal to sine x. In which interval? In the closed interval of 0 to 2 pi. This is the graph. Now we will draw the graph of the trigonometric function y is equal to 3 into sine of 2x minus 4. And we know that what is the maximum value sine of 2x minus 4. We know that sine of 2x minus 4 is always greater than equal to minus 1 and it is always less than equal to plus 1. So that implies that minus 3 is less than equal to 3 sine of 2x minus 4 and that is less than equal to plus 3. So its value is always greater than equal to minus 3, less than equal to plus 3. Again, here you see that we will see that when this sine of 2x minus 4 will be 0. Sine of 2x minus 4 will be 0 if 2x minus 4 is equal to 0. That implies that x is equal to 2. That implies x is equal to 2. Again we will consider then where sine of 2x minus 4 will be 0 if 2x minus 4 will be equal to your pi. If 2x minus 4 will be pi, then sine of pi is equal to 0. So from here we are getting that x is equal to how much? X is equal to pi by 2 plus 2. Plus 2. Again we will find out that when sine of 2x minus 4 will be 0, if 2x minus 4 will be equal to your 2 pi. Will be equal to your 2 pi. That means from here we are getting that x is equal to your pi plus 2. So next we can say that it will be 0. It will be 0 when sine of 2x minus 4 will be 0 if x will be equal to your 3 pi by 2 plus 2. Again it will be 0. So it is very simple thing to draw the curve of this. So here you see that we will draw a number line. Suppose this point is x is equal to, suppose this point is x is equal to 2. Suppose it is x is equal to 2. X is equal to 2. We will draw this to be y-axis. This is 0 and it is your plus 3, 0, 3. This is your 0 minus 3. 0 minus 3. So for x is equal to 2, sine of 2x minus 4 will be equal to 0. It will be 0. At which point? At x is equal to 2. Again, it will be 0 if this point is pi by 2 plus 2. It will be 0 here again. Again, it will be sine of 2x, 3 into sine of 2x minus 4 will be 0 for x is equal to pi by 2, pi plus 2. Again, it will be 0 at pi plus 2. Again, it will be 0 at 3 pi plus 2. 3 pi plus 2. 3 pi by 2 plus 2. So, here you see that the curve 3 into sine of 2x plus. So, here you see that sine of 3 into sine of 2x minus 4 will be 0 at x is equal to 2. It will be 0. And it will be equal to your 3. It will be equal to 3 at which point? At the point pi by 4. Pi by 4. This midpoint of these two. 2 and pi by 2 plus 2. Its midpoint is pi by 4. Pi by 4 plus 2. It will be at this point it will be equal to your maximum value. That means it will be equal to 3. So the curve is like this. The curve will be like this. Again it will be 0 at which point? At pi by 2 plus 2. At this point sine of 2x plus 3 into sine of 2x minus 4 will be 0. Again at the midpoint of these two. So what is the midpoint of pi by 2 and pi? So midpoint is nothing but that is equal to your 3 pi by 2. 3 pi by 2 plus 2. At this point it will be again equal to minus 3. It is equal to minus 3. Here again it will be 0 at pi plus 2. Again it will be 0 at this point. So here what is the midpoint of these two? Pi plus 2, 3 pi by 2 plus 2. Midpoint is your 5 pi by 4. 5 pi by 4 plus 2, it will be again equal to plus 3. So this is the graph of 3 into sine of 2x minus 4. Its graph is like this, and this is the maximum value and this is the minimum value. So maximum value is 3 and minimum value is minus 3. So it will be like this. It is the curve y is equal to 3 into sine of 2x minus 3j. Find the radius of curvature at origin 0, 0 for the curve this. But here you see, before going to find the radius of curvature for this curve, we have to know that what is Newtonian method. Newtonian method. What is Newtonian method for radius of curvature? For radius of curvature. For radius of curvature. What is that method? Here you see that first we have to see that whether the given curve is passing through origin or not. So first you verify that this curve is passing through the origin or not. Next, here first that curve is passing, we have to verify whether it is passing through origin. Yes, because for x to be 0 and y to be 0, this equation is, we are getting 0. So that means the given curve is passing through the origin. Is passing through the origin. Passing through the origin. Next, how to find out the equation of the tangent at the origin? We know that the equation of the tangent at the origin can be found out by equating the lowest degree terms. Lowest degree means it is 2x. So here the equation of the tangent at the origin, equation of the tangent at origin, tangent at the origin can be found out by equating the lowest degree term. Which one is the lowest degree term? 2x. So 2x is equal to 0. That implies that x is equal to 0. X is equal to 0. So x is equal to 0 is nothing but y-axis. It is the y-axis. So here you see that if this curve is passing through the origin and the equation of the tangent at the origin is y-axis, then according to Newtonian method for radius of curvature, so here the radius of curvature can be obtained, that is rho is equal to nothing but limit y tends to 0. Limit y tends to 0. It is y square divided by 2x. Y square divided by 2x. If it will satisfy these two conditions, that means if that curve is passing through the origin and the equation of the tangent at the origin is y-axis, then directly you can find out the radius of curvature is equal to limit y tends to 0, y square by 2x. Now it is the formula for radius of curvature. So here you see that this, we have observed that this curve is passing through the origin and y-axis is the tangent at the origin. So you divide the entire equation with 2x. Now on dividing entire equation with 2x, we are getting it is 2x cube plus 2x. Here it is only x cube plus 3y to the power 4 divided by 2x plus your 4x square, that means 2 into x square y divided by x, plus here it is xy divided by 2x minus y square divided by 2x plus 1 is equal to 0. So here x cancelled out. Here x cancelled out. Now we know that when limit y tends to 0, for x to be 0 and y to be 0, all the terms will be tend to 0 excepting these two. Excepting these two terms. So here 2x is concerned. So all the terms will tend to 0 excepting these two, and we know that when taking limit, when y tends to 0, when y tends to 0, your y square by 2x tends to rho, radius of curvature. So here directly we are getting that taking limit y tends to 0, we are getting that minus rho plus 1 is equal to 0. That implies that rho is equal to 1. So here the radius of curvature of this curve is nothing but that is equal to rho is equal to 1. So that's all.